All right, our last functions for this video are exponential and log functions. The reason I put exponential and log together is because they are inverses of each other. So an exponential function, this is the general form of an exponential function. The other form that you might remember is PERT from pre-calc. That's another exponential, so another example would be y equals e to the RT. The biggest thing is that in order to be an exponential function, your variable is in the exponent, and t is our variable here. Okay, so you have a variable in the exponent. So y equals 3 to the x, that's an example of an exponential. Y equals e to the x, that's also an exponential. Anything that has a variable in the exponent is an exponential function. When we have our y equals a b to the x, if b, whatever is being raised to the exponent, is a number bigger than 1, it is exponential growth. So as you read it from left to right, the graph goes up. If b is a number less than 1, then it's exponential decay. Okay, so we're going down from left to right. Okay, so that's your growth and your decay. Okay, so that is your exponential function. Lesson 1 or section 1.5, we go into exponentials a little bit more. Then we would have our log functions. Logs undo exponential. Okay, they are inverses of exponential functions. So we got log base b of x listed here. And so here is an exponential function graphed. B is some number, so let's just say it's y equals 2 to the x. That's what b is. And so then the inverse of y equals 2 to the x, who undoes that, would be log base 2 of x. Those two are exponential. In terms of graphs, exponentials always look like this. They get really, really close to the x-axis but never touch, and then increase exponentially, or they decrease. And then all inverses always go across the line y equals x. Okay, so if I were to take my exponential function and flip it across this line, this is the graph of a log function. There is an asymptote here, so your log function will never touch your y-axis. Okay, exponential never touches x-axis, log function never touches your y-axis, and that's just because of the way we flip it. Okay, one thing we should talk about really quick is maybe the domain of a log function. It will never touch this y-axis. Okay, so you can never plug in negative numbers, and you can never plug in 0. So the domain is 0 until infinity, and you can't equal 0, so it's parenthesis, and then it goes on to infinity. Okay. Maybe we'll talk about the range really quick of it too, because I feel like that comes up and we forget. The range of a log function, even though there's an asymptote here, this does continue to go all the way down, and then this continues to go up. So the range is actually negative infinity to infinity. Okay, so that is your domain and your range for your log. Maybe since I did that, we should quickly go back and do the domain and range for an exponential. For an exponential domain, this will continue to go on all the way to the left. It just will never cross your x-axis, and it'll continue to go all the way up. So negative infinity to infinity. And then our range, since it will never touch that x-axis, we get really close to 0, but we never touch it, so we have 0, and it's a parenthesis, and then it'll continue to go up. Okay, so that's your range for your exponential. So that's visually what your exponentials look like, and your log functions. Okay, and that is it for lesson 1.2.